Yesterday we started Unit 12 and we did some constructions in geometry where you were actually sketching out, drawing, and building different geometrical figures. What we're going to talk about today is transformations, and we're going to talk specifically about one type of transformation, which is called a translation. But before we talk about translations, we need to know, what are transformations? In geometry, transformations are when you change a figure's position or size to create a new figure. So it would be like taking something and rotating it around, or taking something and making a reflection of it, or just moving something up, down, or left, or right, or you could even change its size. So a transformation is when you change a figure's position or size to create a new figure. That new figure that you create with your transformation is called an image. Okay? So we created an image, we created another image, we created another image, and we transformed that first R to make this image as well. So a transformation is kind of just what it sounds like. It's a way to change something into a new image. And there's lots of different ways that you can transform things. So when we took that R and just slid it up and to the right, that's one way to change it. We changed its position. That is called a translation. A translation is when you don't rotate it or spin it or flip it or turn it, you just kind of scoot it over or scoot it up or slide it to the left or glide it downwards or move it. Okay, so a translation is when you move a figure up, down, left, or right to create a new image. Pretty simple concept. All right, so let's take a look at what a translation might look like in geometry. Right here we have a trapezoid, trapezoid ABCD. Hopefully you understand why that's a trapezoid. Two of the segments are parallel and two of the segments are not parallel. What we could do is we could translate that trapezoid left, right, up, down, or some combination of both. So let's say I want to translate that trapezoid up 4 steps and right 4 steps. What I would do is I would start with point A, and I would move point A up 4 and over 4, and then I would put a new dot. And I want to show that this new dot is like a new version of point A, but I don't want to call it point A because point A is already taken. So I'm going to call it point A with a little apostrophe. And that little apostrophe in geometry, we read it as A prime. A prime. And the prime is just how we show that that point A is an image that came from the other point A. Hopefully that kind of makes sense. Okay, so we've got an A prime, and then we're going to make a B prime. So we're going to move B up 4 and over 4 and put a B prime. And then we're going to take point C, move it up 4 and over 4 and put a C prime. And then we're going to do that with point D and put a D prime. And what do you know? Next thing we know, we took our trapezoid and we translated it. Basically, didn't we just slide that whole trapezoid up and to the right? Yeah, that's a translation. And take a look at the coordinates. The original point A was at -6, 5. Now we said we moved that point up 4 and over 4. Well, when we did that, A prime is at -2, 9. Notice, if we added 4 to the x coordinate, you get -2. And if you added 4 to the y coordinate, you get 9. So that's what we basically did to every coordinate for every point. If you take B and add 4 and add 4, you're going to get B prime. And if you take C and add 4 and add 4, you're going to get C prime. And if you take D and look at D prime is -5 plus 4 and +2 plus 4. So what we basically did is we took every set of coordinates, every x coordinate and every y coordinate, and we changed it so that the x coordinate was 4 more than it was in the first place, and the y coordinate was 4 more than it was in the first place. This way of writing this, with an arrow and an x comma y and then an x plus 4 and then a y plus 4, is what we call arrow notation. Arrow notation uses an arrow to show what happens to translate the original coordinates into the new coordinates of the new image. So what this rule basically says is you take every x coordinate and you add 4, and you take every y coordinate and you add 4. And that tells us that we went forward 4 spots and that we went up 4 spots, and that we're doing it to every point on that shape so that we get a congruent shape to what we originally had. It's just a new image, a new version of that shape that's translated forward and up. If I gave you arrow notation that looked like this, what we would be doing is we would be taking every x coordinate and moving them backwards 9 spots. And we would take every y coordinate and move it down 1 spot. Can you see why it's backwards and down this time instead of forwards and up? It's because of the minuses. Okay. What about this one? Take a second and see what you think is going to happen as far as going up or down or left or right. Okay, well, if you guessed that the x number is our forward backward number, and that means that our x is going forward 7 and our y is our up down number, and therefore our y minus 3 tells us that we're going down 3 spots, you were correct, because the x part always tells us our forward backward position and the y part always tells us our up down position. So a plus 7 on the x means we're going up 7. No, that's not true. That was a typo. That should be all points move forward 7 spots or to the right 7 spots, not all points move up 7 spots. Typo. Sorry about that. But the second part, y minus 3, is correct. All points move down 3 spots. All right, by the way, the x being the forward backward is another way of saying the left right. Okay, let's summarize. A translation is when you move a figure up, down, left, or right to make a new image. It's pretty easy. A translation is just a move. Arrow notation tells you which directions to move something and how much. It tells you to go right so many, or forward so many, or backward or left so many, or it tells you how many to go up or down. You just have to look at the pluses and minuses and the numbers in those blanks. So, try this. If you had this translation, would you be going up, down, left, right, and how much? This arrow notation means that all points move blank spaces in blank direction and blank spaces in blank direction. Okay, how about this? Same idea. This arrow notation means that all of your points are going to move how many spaces in what direction and then how many spaces in what other direction. All right, one more practice problem for you and then you're done. I want you to write arrow notation for the translation that you are about to witness. All right, here's triangle ABC. Here's triangle A prime, B prime, C prime. Write arrow notation, x, comma, y, and then an arrow, and then x plus or minus something, comma, y plus or minus something, to show what happened to triangle ABC to turn it into triangle A prime, B prime, C prime. All right, that's it.